Hi there. So in order for us to understand how to use angles that are greater than 90 degrees with sine, cos, and tan, we have to kind of figure out what's happening. And a way to do that is for us to make all the angles in a standard position. Okay, and we're going to put them on kind of like an XY coordinate system. All right, so I'm going to sketch 70 degrees in standard position. So here's how I'm going to do it. I'm going to start by making the first part of my angle here. Okay, I'm going to put the vertex of the angle on the origin. Remember, vertex kind of means corner. And then I'm going to open up 70 degrees. Okay, so if I go this way, 70 degrees, I would say I would stop about there. Okay, 90 degrees would be pointing all the way up. So 70 degrees would be about there. So I've just drawn 70 degrees in standard position. Okay, this thing where it starts here is called the initial arm. Okay, start. This arm, kind of where it kind of opens, is where it stops. So that's the terminal arm. And the angle, of course, I also want to say we're going kind of counterclockwise, right? So we're going always that direction in standard position, and when we do a positive angle, and yeah, that's pretty much it. Okay. So when you're doing it, I'm just going to see these red lines here don't work nicely, but it's kind of like we're going like this. We're opening up clockwise and sort of getting bigger and bigger angles by spinning around this direction. Okay. So that would be 45 degrees, that would be 70 degrees, that would be like 90 degrees, and so on. All right. So in the next section here, I'd like you guys to try and draw those angles. Okay, so you can pause the video, and now I'm going to do it. So 25 degrees. So our initial arm starts there, and 25 degrees, well, I know that like halfway would be 45 like that. So 25 degrees would be me, like, say, going about there. So there's 25. And let's put the direction of opening as well, going counterclockwise like so. 190 degrees, well, I'm going to start there. Now, if I go around, spinning around the center, straight up would be 90 degrees. Halfway around would be 180 degrees. So I want to go just a little bit past that. So 190 degrees would be just a little bit past 180 degrees. Okay? 280 degrees. All right, so again, starting with our initial arm and opening 90, 180. 3/4 of a circle is 270. So I want to go 10 degrees past 270, and that's 280 degrees. Direction of opening is counterclockwise as always. It's also possible for us to do things like 370 degrees, right? 360 degrees is a full circle. So if I go all the way around, I've just gone 360 degrees, 10 degrees more would take me to about there. So a full spin around plus 10 degrees more is 370 degrees. All right, and the last one here, it's not something we're going to be dealing with a lot this year, is a negative angle. Well, you can imagine that's just opening backwards, right? So instead of going forwards, 45 degrees, I'm going to go backwards 45 degrees. So that would be negative 45 degrees. Okay? So that arrow showing the direction of opening is kind of important. All right, so next thing that we can do is we can talk about the difference between an angle in standard position and a reference angle. Okay, so let's say I'm going to draw, let's say 120 degrees. All right, so 120 degrees, well, 90 degrees would be straight up. So I'm going to go all the way around 90 degrees plus about 30 more, because 90 and 30 take me to 120 degrees. Okay, so there's 120 degrees in standard position. So the reference angle is the name given to the acute angle. Okay, acute means less than 90. That is between the terminal arm and the closest x-axis. So the closest x-axis is down there. So that angle is always called the reference angle, and it's always going to be less than 90 degrees, no matter how you do it. So if this is theta, this little guy in here we're going to call theta sub r. So a little subscript r there. And in this case, it's going to be 60 degrees. Okay? So every angle that we draw, there's the angle itself, and then there's the reference angle. Okay? And it's always kind of has to do with going between the terminal arm and the closest x-axis. So let's look at some other examples of things in different quadrants and see sort of how it all shakes down. So sketch each angle in standard position, label the angle and the reference angle. In each case, give the size of the reference angle. Alrighty. So 160 degrees. 160 degrees? Well, 180 is all the way around, so we're going to stop short of 180, 20 degrees. So if this is 160 degrees, then again, I stopped short of 180 degrees. I stopped 20 degrees short. Well, that little area under there, that acute angle, theta r, is 20 degrees. And 160 is still the main angle. All right, so the reference angle is kind of how close we are in relation to that sort of like that part of the x-axis. 225 degrees. Okay, so 225 degrees is bigger than 180 degrees, so I know I'm going to go past it. 225 minus 180. Well, that's going to be 45 degrees past 180. So let's do that. 90, 180, 45 degrees more takes us to 225 degrees. So the angle is 225 degrees. But this time, if we take the terminal arm and the closest x-axis, it's there. So the reference angle is how much past 180 we are. Okay? So in A, it was how much sort of short of 180 are we? And this one here is how much past 180. Okay? Why is it 180 in both cases? Well, because this part of the x-axis, that's represents kind of like where we'd be at 180 degrees in standard position. So it's kind of all in relation to that. Now let's look at 310 degrees. 310 degrees, well, straight up's 90. This is 180. Down here is 270. So we know we're going to have to go past 270. Well, that's one way of thinking about it, is we're going to go past 270. Another way of thinking about it is all the way around is 360. So I know I'm going to stop short of 360 degrees, 50 degrees short. 50 degrees before 360. So if there is my angle of 310 degrees, down here is how much, again, all the way around takes me to that part of the x-axis. So how much short of 360 degrees are we? We are 50 degrees short, and that's our reference angle. Now what happens when we're in the first quadrant? Well, 85 degrees. We're just going to open this way, like so. So 85 degrees is the angle. And when we're in this quadrant, it just so happens the closest x-axis is kind of where we started. So in this quadrant, theta r is actually, the reference angle is actually 85 as well. So let's stand back and take a look at what we've done here. Okay, we've got, by the way, and hopefully you guys remember this from last year, but the quadrants are, when we're in this quadrant, it's quadrant 1. I don't have them nicely labeled here. Here is quadrant 2, right? Here's quadrant 3, and here's quadrant 4. Okay, so when we're in quadrant 1 down here, when we're in quadrant 1, the reference angle and the angle are just the same. And we're over here in quadrant 4, you know, since that's closest to 360 degrees, it's kind of like our distance. The reference angle is the distance we are away from 360. And in the top two, it was the difference we are away from 180. So I'm just going to write that down here. So here, in this quadrant, it's sort of how short of 360, and here they're the same. All right, so we'll get used to that more as it goes on. The last thing we're going to look at here is, in this video, is reference triangles. Okay, so let's draw an angle in standard position. Let's do it this time in quadrant 3. So I'm going to go around through quadrant 1, through quadrant 2, and I'm going to stop here at, all right, I'm going to make that, say, 240 degrees. Okay? The reference angle is how much past 180 we are, okay, because it's always between the terminal arm and the closest x-axis. So 180 is halfway around, so 240 minus 180 gives us 60 degrees. So we're 60 degrees past that little sort of midway mark, and that's our reference angle. All a reference triangle is if we say, let's sort of take that little reference angle and let's make that into a reference triangle by dropping a side perpendicular to the x-axis that meets the terminal arm like so. So in quadrant 3, that little triangle that I've drawn there is called the reference triangle. All right, so the reference triangle, it kind of depends where the angle stops as to where, sort of how it looks and in what quadrant you'll draw it in. So let's draw the reference triangle for A, B, C, and D. Okay, so we had said before that there was a connection between 50 degrees and 130 degrees in the introduction. So let's kind of draw it. Let's start here in quadrant 1. Okay, so I'm going to start with B. 50 degrees, if I open 50 degrees, that's just a little bit past the 45-degree angle. So there's 50. Okay? 130 degrees right next to it is me going 90 degrees plus 40 more. Okay? So what's the connection between those two angles after all? Well, let's draw in the reference triangle. Okay, in quadrant 1 here, it's just straight down between the terminal arm and the x-axis. Over here, between the terminal arm and the x-axis, makes me draw it there. Okay, this is quadrant 2. Now, what's the reference angle in this case? Well, the reference angle down here is how much short of 180 degrees we are. We are 50 degrees short. So what is the connection between 130 and 50 degrees? Well, they both have the same reference triangle. It's just really a 50-degree right triangle, but drawn kind of in a different spot. Okay? So down here, that's going to happen again. 230 degrees is, if we subtract 180, we can see that's 50 degrees past 180. So let's draw 230 degrees in standard position. 90, 180, an additional 50. takes me to down there. 230 degrees is that big angle. Let's draw in the reference triangle. Reference triangle is always between the terminal arm and the x-axis, so it's right there. All right, so what is its reference? What is that reference triangle's little reference angle? Well, that's down here, and we've already kind of worked out that that's 50 degrees past 180. So there we are with yet another right triangle. Okay, a reference triangle that that is kind of connected. I don't even know. I've been making lots of videos. I don't know how to end that sentence, so I'm just going to end it just by trailing off, mumbling. There we go. Okay. All right, so the last one, that was quadrant 3, by the way. All right. The last one here is quadrant 4. Now, let's draw a reference angle and a reference triangle that's going to be a 50-degree triangle, but let's draw it in the last quadrant. So I'm going to go all the way this way. I'm going to stop 50 degrees short of going all the way around, so that I have, just like all the other ones, a reference triangle in the fourth quadrant. Well, what would that make this final angle have to be? If you think about it, I almost went all the way around. I almost went 360 degrees, but I stopped 50 degrees short of going all the way around. That would make this 310 degrees. Okay? So 310 degrees is connected to the rest of those angles, in that all four of those angles, 50, 130, 230, and 310, all are connected by the fact that they have the same reference angle. So let's pull up our calculator here, and 1 second, I'm just going to get to work. There we go. All right, so what I'm going to do is I'm going to, let's say, find the cosine of each of those angles. And let's just see how they're all related. Cosine of 50 is that. Cosine of 130 is that. Cosine of 230 is that. And tan of 230, no, cosine of 310, the last angle, is that. Okay, so we got to see all those here on there. Now, this top one here is cos of 50 degrees. Now notice they're all basically the same number, but two of them are negative. 130 and 230, those ones are negative, and the other two are positive. So what we got to try to figure out is, why do these ones have a cosine that's negative, and why do these ones have a cosine that's positive? Okay, the same number, but one side's negative, one side's positive. All right, let's take a look at what the sines would be. Okay, so sine of 50, sine of 130, oops. Okay, we've got sine of 230. You can see all the same numbers, right? Except now we're starting to get some negative results. And then sine of 310 looks like that. So they're all 0.766. 230 and 310 give us negatives. The other ones give us positives. So for sine, why are those two giving us negative answers, and why are those two giving us positive numbers? Okay, so in videos coming up, we're going to take a look at why exactly that is.